In question 11, it is a question about area and volume again. And then they say that there is a white circular conical vessel. So inverted. So it's like this. Like this. It seems like a paper cup. And then they say that they are contain some milk originally. So maybe some milk here. And then the depth here is 12. After that, Peter put some more milk inside, so it's become more. And this region, the volume is 444 pi cm cube. And then now the total height is 60 now. And then we are going to express the volume of milk in terms of pi. It's definitely a question asks you to apply the volume ratio by the given length ratio. So the original milk are similar to the extra together with the original milk. And then we have their length ratio, which is 12. And another part is 16. Then we can write down L1 to L2 is equal to 12 to 16. Simplify it. Both divided by 4. We get 3 to 4. This is L1 to L2. The volume ratio are not exactly the same, but they are related. They should be related. So that's why we know the volume ratio is equal to 3 power 3 to 4 power 3. We know that they are related in this way. So it's 27 to 64. And then you are going to let this one, the volume is 27K. Then this one will be, the total is 64K. What they tell you is the blue part. This frustum is 444 pi. And how we get this frustum is we use the total height and then we subtract the smaller cone. That's how we get the volume of frustum. We already let the large cone be 64K cm cube and the small cone become 27K cm cube. So by doing this, we can build up equations with K be the unknown. Then we can sort out how large is each unit. So 444 pi is equal to 64K and then minus 27 units. So each unit is 444 pi divided by 37. K is equal to 12 pi. And then what it's asking is we have to find out the final volume. That means the final volume is this one. That's why the final volume is 64K. That means 768 pi cm cube. This is the simplest method and the most clear method. By using the given length ratio, you know that height ratio, that means length ratio. Then we get the volume ratio. After that, by the given volume ratio, we let two items be 27K and 64K, so that we know how to build up the equation to make good use of this information here. Then we find K, that means each unit is 12 pi. And then our target, we have 64 units there. That's why 64 times 12 pi, we get the exact values. Another method for part A is consider the cross-section triangle. So we have a big triangle and also a smaller triangle which are similar about their cross-section. The height here is 12 and 16. So that's why we know that the ratio is 3 to 4. Another method is to let this one be 3 out and let this radius before R because we know that they are similar. So 3 to 4 here, the radius should be 3 to 4 also. And then after that, we calculate the volume of the original part, the smaller part, with base 3R and 12. Then we get it is 1 over 3 pi R square times height. Similar reason, we get the volume of total, which is the width is 4R and then the height is 16. So we get 1 over 3 pi 4R bracket square times 16. And then again, we know that the blue part, that means the differences is 444. We just use this item minus this, give us 444 pi. So we can write down 1 over 3 pi times 4R bracket square times 16. And then minus the smaller one times 12. And then is equal to 444 pi. By solving this, you get what is R, then you know what is the exact values of the total milk radius. And then you can still get the same answer. Part B, they say we have to find out the final area of the red curved surface. First, from blue to red, this is the total volume of milk. And then the surface is touched are all red, and also curved. And then for a cone with the base radius R and H and the slant height L, we know that the curved surface is equal to pi RL. That's the formula that you need to remember. So our target is to find out what is R of the total milk surface and what is the slant height. So assume that we use the first method in part A, so we don't know what is R here yet. We let it be R. That's why the volume is already proved is equal to 768 pi is equal to 1 over 3 pi R squared times the height we know is 16. Then we try to solve this one. R squared equal to 144, so R is equal to 12. We know that the base is 12. After that, we also need to know the slant height. If we just focus on the cross section, this is a right angle triangle. The height is 16, the base is 12. So by the Pythagoras theorem, L squared is equal to 12 squared plus 16 squared. Or if you know it is 3 to 4 to 5, then we get L is equal to 20 directly. Now we have all the items we need. We have R, we have L. So get the final answer. Pi R is 12 while L is 20. And then they say we need to compare with 800, so we have to use our calculator to get the exact values. Then we get 753.98 something cm square, which is smaller than 800. And then they say at least is 800, but the outcome is less than 800, so we don't agree the statement. Do not agree.